you? Well, what element has 1,800 protons, electrons? None of them. This guy right here only has 118 electrons. That's not, we're close to 1,800. So in our class, in the world of mass, who doesn't count? Who doesn't count? Protons, neutrons, electrons. Electrons, thank you. So when we're talking about the world of mass, we're talking about the world of the nucleus. And we're talking about protons and neutrons. You got it? All right, so here, look down here, look at the model. Take a look at the model of the atom here. Look at the nucleus. What is the atomic number? The atomic number is always the number of protons. How many protons do you see here? 3. The atomic number 3 will always be what element? Lithium. Pretty easy. What is the mass number? The mass number is the number of protons and neutrons. I have 3 protons. I have 4 neutrons, 7. Mass number is 7 for this isotope. Anyway, how do I write the symbol for this isotope? I write the Li. I put down here the atomic number down here. That's the atomic number of protons, right? And what's this number here? What is this upper left-hand corner for? What's the upper left-hand corner used for? The mass number. That's the world of mass, isn't it? What if you took the mass number and subtracted the atomic number? What would you get? Protons and neutrons minus protons. It would give you neutrons, wouldn't it? So how many neutrons does this isotope have? 4. Pretty nice, huh? What if we had another lithium atom that didn't have one of these neutrons? I'd have to say it was a lithium 6. Are you with me? I'll keep looking at your faces. I can't tell if you're just tired. What do you think? Would it still be lithium, though? Yeah, because it has 3 protons. And then we flip this over. Flip this over. We have 3 different atoms here. What's the atomic number of this one? 1, 1, and 1. That means all of them have to be hydrogen. They all have to be hydrogen because they have the atomic number 1. But what's the mass number of this one? Remember, electrons don't count in the world of mass. Your mass number is 1. Your mass number is 2. Your mass number is 3. And how do I tell you that? How do I tell you that these are not the same? This is hydrogen, whose mass is 1, hydrogen whose mass is 2, and hydrogen whose mass is 3. It just so happens that there are 3 isotopes of hydrogen, that's all, and only one of them is radioactive. So only one of them could actually hurt you if you were to swallow it. And they're so rare, it takes a long time to get a lot of these guys here. It's also the only 3 isotopes I know of that scientists gave a name to. They did not give a name. Here's the name of this isotope: carbon-14, uranium-235. But these 3 actually have names. Protium, like prototype, is the first. Deuterium has a mass of 2, a duet, 2 people singing a duet. And tritium has a mass of 3, and 3 people. Tri means 3, doesn't it? Triangle, tricycle. Everybody get that? All right, you okay with that? What do you call atoms of the same element, but they have different masses because the number of neutrons are different? What do you call those? What do you call these 3 things? They're all what? Starts with I. No. They're all isotopes of what element? See that? Now, I don't memorize all the isotopes. I think, who knows, uranium might have 6 isotopes, or copper may have, I think it only has 2. I'd have to look up how many isotopes. Some of them have 7 isotopes. Anyway, that is the world of mass. Now let's go back over there, climb over that brick wall. And remember, this is probably the 4th time I've done this, maybe the 3rd, and I probably won't do this again. So stay with me. In the world of charge, I'm not worried about mass. I'm worried about who has an electrical charge. And they found out that protons have a charge, and it was so many coulombs, and they changed that number into 1. And electrons also had the same amount of charge, but it was opposite charge. So they call this one +1, -1. And neutrons had no charge. So in the world of mass, we don't talk about electrons. In the world of charge, we don't talk about what? We don't talk about neutrons. Okay, now, look over here. Look at this atom here. He has 3 protons and 3 electrons. I call it an atom. Atoms are neutral. Isn't that right? But I happen to know that in chemistry, metals have a tendency to lose 1, 2, or 3 of their electrons. What if lithium were to lose 1 of its negative electrons? Then it would have 2 electrons and 3 protons. What would happen now? I couldn't call it a neutral atom anymore. What would I have to call it? It's a +1. +1. What's that I word now? What's the new I word? Not isotope, but ion. Now, how would I let you know that this is not a neutral atom anymore? This is actually an ion. How do I do that? That goes right here, doesn't it? What if you see nothing written here? What if you see nothing written here, but you know you have 3 protons? How can it be no charge and you know you have 3 protons? You must have how many electrons? What do you think?
4.
Try it again. If you see nothing here and you know you have 3 protons, then how many electrons do you have to have? How can you have no charge and I know you have 3 protons? Come on. Thomas, help me out. Help me out, Thomas. You can do it. What do you think, Thomas? How can you have no charge? And when I put nothing there, it means I have no charge. How can you have no charge when I know you have 3 protons? Yes, what do you think?
You have 3 electrons.
You have 3 electrons. Take a look up here. Look at uranium. Uranium. How many protons does it have? 92. Well, there's nothing indicating that's an ion, so it must have how many electrons? Try it again. You have 92 plus charges, and you have no charge. You must have 92 electrons, right? How about this guy, sodium? 11 protons. How many electrons do you have? 11, unless you're an ion, right? It's not an ion. All right, so what we're going to do is, let me show you how much information I can get from this symbol right here, okay? Now you're going to be playing the grid game in a minute. First of all, I see Na. What does Na tell me? What is the element? Sodium. What else do you know about Na? What is this called? What's that called? Yes. And what does the atomic number tell you? Right. Very, very good. So, watch. I know it's sodium. I know its atomic number is 11, and that means I have 11 protons. Okay? Now, what does this number tell me? What's this called? The mass number. That's the number of things in a nucleus, right? Protons and neutrons. So if there are 24 things in a nucleus and 11 of them are protons, how many neutrons do I have?
13.
I have 13 neutrons, don't I? So this isotope, that's world of mass, this isotope of sodium has a mass of 24. Now, let's look at the world of charge now. What does this tell me? Do you have more pluses or more minuses?
More pluses.
Pluses are ahead by 1. But how many pluses did you say you had? If you have 11 pluses and you're ahead by 1, then how many negatives do you have? 10. I have 10 electrons. See all the information I got just from that symbol if you know how to read it? All right, let's flip it over. All right. If you are looking at your chapter, if you're looking at the chapter at all, there's a section where it shows you, and I'll show you a picture right here. Whoops, skipped it. Yep. Where is that thing? Huh. Oh, there it is. Sorry. All right, look right here. See that picture right there? What is that? That picture is going to be really important for the rest of the year. Most of the elements, not counting hydrogen, okay? But see this little stair step here? Everybody who's down here, all these elements are what? What's the general word for these kind of elements?
Solids.
What is it?
Solids.
Okay, that's a good question. I'm glad you brought that up.
Positive.
Everything that has a black lettering, that means you're a solid at room temperature. So we have some solids over here too. But everything that's red is what?
Gas.
Is a gas. And everything that's blue is a liquid at room temperature. So we got that out of the way. But what do you call everything except for hydrogen that's below this stair step? Metals. And metals have in a chemical reaction have a tendency to lose some of their negative electrons. Now listen, you got to twist your brain here. If metals have a tendency to lose some of their negative electrons, what kind of an ion do they become? What charge of an ion would they have? If you lose some of your negative things, what if you have the same number of pluses and minuses and you lose some of your minuses? Then you become a positive ion. Now, over here, including hydrogen, and through here, these are called the nonmetals. In a chemical reaction, they tend to want to steal or take away or gain 1, 2, or 3 electrons. What if they were neutral and then they get a negative electron? What kind of an ion do they become? A negative ion. So look at this story here. We'll finish the story. All right, so here's what happens. I have some lithium here. And again, I kind of hate that this is what I'm doing here on the first day back, but it just happened to be that it got split. Uh-oh. Oh, that's interesting. Oh, it kicked me off.
It's the restroom movement.
Yeah, kicked me off. Oh, interesting. All right, here we go. Almost done. Ready? I got some time. All right, here we go. So here's a metal, and metals have a tendency to lose negative electrons, and lithium likes to lose 1. So look at lithium. Lithium was a regular atom to begin with. We bring it close to a chlorine atom. So nonmetals want to gain, you want to lose. So here's what happens. This guy loses an electron, he's not going to get it back, and he becomes an ion. Now, what's the special name? What's the fancy name for a positive ion? It's called a cation, and I'll tell you how I remember that. I spell the word cation, I spell the T like a plus sign, and that's my memory trick that cations are positive ions. All right, so metals tend to become cations. All right, what about this guy over here who was neutral to begin with, but then he gained an extra negative? Well, then he becomes a negative ion. A fancy name for that, here's your memory trick, a negative ion. So anions are a negative ion. Now something weird happens. For the first time this year, I've talked about 2 elements coming together, and they cannot come apart. They have a bond that keeps a chemical bond that holds them together. And here we go. Ready? What do you call, why doesn't this ion and this ion, why do they stick together? Why do they stick together? This is something you usually teach in elementary or middle school science. Things that have opposite charges do what? Attract. And so what do you call the bond between a positive ion and a negative ion? What would be a great name for that kind of a bond? Starts with an I. Ionic bond between ions. You get it? what are ionic compounds made of? Starts with I. Ions. Ready? And hang on. And there's one other word. Wait a minute. And now there's a word in chemistry that means you're an ionic compound. And again, metal, non-metal. Metal, non-metal. And here it is right here. The word that means you're an ionic compound is a salt. Now, there are hundreds of salts. It just so happens that one salt is the one that's in your house. There's one salt that you put in a salt shaker, and that happens to be a metal, sodium, combined with a non-metal, chlorine. Sodium chloride is the only salt that you know of in your household. But in the ocean, there are 15, 16 kinds of salt. Magnesium chloride, barium fluoride. Okay, now, that took me a little longer than I thought to review.